Hello and welcome to WESTPAK's webinar entitled Top Failures Observed During Gross Leak Detection and Seal Strength Testing of Medical Device Packaging. Hi there, I am Tim Eels and I'll be your moderator and webinar organizer today. Before we start, let's take a moment to ensure that everyone is ready and familiar with the webinar control panel. First, you should have a control panel on the right side of your screen, which you can minimize by clicking the orange arrow button in the upper left-hand corner of that screen. You can also expand it by clicking the same button. Also, you have the ability to submit questions using the chat pane. It's located near the bottom of that control panel. We'll be answering a few questions during the webinar today. However, if we're unable to address your questions, either Greg or I will follow up with you by email afterwards. For those of you registered and logged into the live webinar, you can download a copy of the slide deck now. You'll find it located in the handout section of the chat pane. It's just above the questions area. Feel free to download it. You can refer to it later. Well, let's get started. Today's presenter is Greg Schwinghammer, who is the general manager here in San Jose. We are a third-party product and package testing laboratory with facilities in San Jose and San Diego, California. Greg began his career here at the San Jose lab in 2001 as a test engineer, shortly after his graduation from San Jose State University with a bachelor's in packaging science. Over the last 18 years, Greg has moved all the way through WESTPAK's engineering and production ranks into the management area. He has a unique combination of being very knowledgeable in all test as well as business areas. In his spare time, Greg enjoys golfing with family and friends, blocking incoming pucks as a goalie on a local ice hockey team, and time at his cabin in the Sierras. Okay, let's get the webinar started. Greg, the audience is ready. Take it away.
Thanks, Tim. Today we're going to talk about sterile-barrier-package systems, or SBSs, gross leak detection bubble testing, and some peel testing, also known as seal strength. First, let's talk about what a packaging system is. It's a combination of a sterile barrier system and protective packaging. The levels of the packaging system are the protective packaging. This is usually the package your product is shipped in, and it's usually made of corrugated fiberboard. The next level of packaging is contained within the shipper. It is either the secondary or tertiary package depending on the number of levels of packaging you have. This is usually a folding carton, a corrugated fiberboard box, or a bag. The final level of the packaging system is the primary package. This is the first level of the packaging and is in direct contact with your product. For a medical device, this package is typically the sterile barrier system, or SBS, usually a breathable pouch or tray that allows for sterilization. For medical devices, it is very important that the unit inside the pouch or tray remains sterile until it is opened. If in an operating room, any breach of the SBS system can potentially kill someone. Therefore, medical device companies go to great lengths to keep the inside of their packages sterile. Now let's talk about gross leak detection. Gross leak or bubble testing is usually conducted per ASTM F2096. It is used to find gross leaks in medical packaging through internal pressurization. The test method is very thorough as it tests the seals as well as the surfaces of your SBS. To conduct this test, you first lower the package system 1 inch below the water. Inflate the package. Once the package is inflated, you look at it for leaks, which are indicated by a steady stream of bubbles. The test is designed to detect holes in your SBS as small as 125 microns. A question we receive a lot is, how is the test pressure determined? Per ASTM F2096, we determine the test pressure by creating a known failure in the package surface with either a 125 or 250 micron wire. We then follow the procedure by submerging the package under the water and slowly inflating the package until we can see the leak. This would give you your minimum test pressure. This test would be conducted slightly higher than the minimum test pressure to increase the likelihood of finding leaks. You can see a gross leak test in action if you follow the link at the bottom of the slide. Now let's talk about failure modes we typically see during gross leak testing. The first failure mode is one of the most common. It is called stress cracking and sometimes more commonly known as flux cracking. The top photo shows an example of stress cracking. The bottom photo is how the failure appears during gross leak testing. The main cause of stress cracking is compound folding. This is generally caused by using pouches that are longer than needed. This makes it so you would need to fold the pouch multiple times before placing it in your folding carton or secondary packaging. The folds of the pouch would get aggravated during distribution. Using a universal package configuration can also cause stress cracking. What do I mean by a universal package configuration? Using the same pouch for multiple products of varying sizes. To help prevent stress cracking, WESTPAK recommends using the proper pouch size to eliminate or reduce the amount of folding needed, or using a stronger, more flexible material such as a nylon laminate. The second failure mode is punctured surfaces caused by protruding objects. We've seen a lot of failures from sharp objects poking through trays and pouches. Also, abrasion due to objects rubbing against the pouch or tray during vibration creates a hole in the SBS. To prevent this failure, we recommend using a device card such as a chipboard card with tabs to hold the device in place. One other thing to remember is with a device card is to round the corners, because sharp corners on a device card can just as easily puncture your SBS as your sharp object. The second recommendation would be to place plastic covers over the tips of your sharp objects. Finally, if you have a product that has a lot of protruding or sharp objects, we recommend using a properly sized thermoform tray to secure the product in place. We recently had a customer that had a device that looked like a small trash can with sharp feet on the base. They originally had it in a nylon Tyvek pouch. It failed the first round of gross leak testing after transit testing. We recommended putting it in a tray. They decided to double pouch the unit instead, reran the test, and had gross leaks on both sets of pouches. They finally went to the recommended tray, and it passed with flying colors. The third failure mode we see a lot of is tray cracking. This can be caused by a few factors. One of which is if your tray material is too stiff. Another is if your tray isn't properly designed. An example of this is having a bend radius that is incorrect. Another cause may be using accelerated aging temperatures that are too high. Using high accelerated aging temperatures can cause the material to transition or degrade. The failure mode is usually manifested during impact testing and is quite obvious during gross leak testing. As you can see in the picture here, the tray is cracked and is obvious even before you start the gross leak test. If you have this issue, we recommend redesigning the tray with the help of your vendor. They can make recommendations on the proper design of the tray and suggest materials that would be less brittle and more ductile. Make sure to check with your vendor on the optimum material to use. If it may cost a bit more upfront to have a proper tray design, but you will save money in the long run with fewer failures and redesigns. Also, make sure that your aging temperatures that you're using are below the transition temperature of your product and packaging material. ASTM F1980, the accelerated aging standard, recommends using temperatures no greater than 60 degrees C. We suggest not exceeding 60 degrees C unless higher temperatures have been evaluated and approved through testing. The last gross leak testing failure mode I would like to talk about is sealing issues. As you can see on the pouch on the left, there are a lot of creases in the seal. This can be caused by folding of the material during the sealing process. The contents inside the pouch can also cause this by shifting into the sealing area during the sealing process. After you have sealed your pouches, you should conduct a visual inspection of the seal prior to testing to identify this issue. The picture of the tray on the right shows a sealing issue that was most likely caused by the improper sealing parameters. such as a sealing temperature that is too low or a sealing duration that was too short. This may have been caused also by imperfections or obstructions located in the sealing surface. To prevent this issue, you can inspect the seal area prior to conducting your sealing. Also, conduct a pre-validation of your sealing parameters prior to conducting a full validation of your package systems. Now let's talk about seal strength testing. Seal strength testing is conducted per ASTM F88 and is used to measure the strength of seals in flexible barrier materials. There are 3 different techniques for conducting the testing per the ASTM F88 standard. Technique A, unsupported. This is commonly used and gives consistent results. Technique B, which is supported at 90 degrees, introduces a human factor that can result in inconsistent results. In my time at WESTPAK, I've never seen anyone use Technique B. Technique C, or supported at 180 degrees like Technique A, is commonly used and gives consistent results. Many pouch and tray vendors we know recommend this technique. One thing to note, with similar seals, you will see higher seal values with Technique C over Technique A. We recommend choosing one technique and staying with it throughout your testing. This way you'll be able to compare your results without the variability of different techniques needed to be taken into account. The biggest issue we see with this test is that companies are selecting a minimum 1 pound force peel strength without conducting any pre-validation testing to determine what their minimum acceptable peel values are. This causes false failures that may not actually be failures. To help prevent this issue, we suggest you first determine what your minimum required peel values are as part of your IQ, OQ, PQ process of your sealing equipment. Here's a short recap of what we've talked about today. There are 4 main failure modes for sterile barrier systems that we observed during gross leak. They are stress cracking, punctured surfaces, tray cracking, and sealing issues. And the biggest issue we see with peel testing is companies selecting a minimum required peel value of 1 pound without doing any pre-validation work. Tim, do we have any questions?
Hey there, Greg. Thanks. That was a great presentation. You got a lot of good material there. My favorite is the pictures. I'm a picture guy. Greg, we've got a couple of questions, and maybe we get going. We'll get some more. First question we have, here it goes. It's about, we didn't talk about it here, but the question was, what is the most commonly used ASTM 4169 assurance level that's used by medical device manufacturers for simulated distribution testing?
That's a good question, Tim. Most medical device customers use assurance level 1, and that's because they want the highest confidence that their packages will survive the distribution environment. So assurance level 1 is the easy short answer there. So what's our next question?
Okay, cool. Greg, there's a question about, I guess this would pertain to gross leak detection. Are there patches or stickers you can attach to problem areas, such as a common pinhole area?
I wouldn't recommend putting patches or stickers over the leak, because if it's a leak in your poly side of your pouch, that could cause additional failures and it may have microbes get in through that same pinhole. I'd recommend changing the configuration of your package inside the pouch or tray to make sure that you don't get punctures from the inside out. So, cool. What's next, Tim?
Okay, Greg, that generated another question regarding peel test. Well, let's see, this is peel test, not gross leak. Is there a requirement to test all sides of a package, or is one side considered adequate?
That would depend on if you're validating your seals or your vendor seals also. If you're just validating your seal, you would want to just check your in-house seal that you formed. If you're validating your vendor seals also, you would check all of them. One recommendation on that is if you are going to validate the vendor seals, you would want to check with the vendor to make sure you use the same technique they do, because if they use technique C and you use technique A, you're going to get vastly different results.
Okay. Greg, we've got a question here about sterile barrier. Can burst testing demonstrate a sterile barrier?
That is a good question. Really, it doesn't check for sterility. It's more similar to the peel test. It gets you a burst value to tell you your seal strength more than was your seal intact.
Okay, good. Thank you. Greg, we have a question about the gross leak detection. The question is, during bubble leak test, how do you inflate porous materials?
The way you inflate porous materials is you would increase the pressure inside the pouch enough that it inflates the pouch. You will have breathing out. It's the classic, if you're filling the math problem, if you're filling a bathtub and it's coming in at 3 gallons a minute and going out at 2 gallons a minute, how long does it take to fill the bathtub? It's the same with inflating a pouch. Tim?
Okay. Greg, there's a question about one of the terms you used in the materials. Can you explain how you would go about determining minimum seal strength using IQ, OQ, PQ?
Using IQ, OQ, PQ, the way you would do it is you would use your validation study, because you're going to do high, nominal, and low values when you're doing your IQ, OQ, PQ. And if you get acceptable values of your nominal value, and you also check that the seals are still intact, you would use that value as your minimum peel value and not just use 1 pound force.
Okay, and Greg, for those people in the audience who may not know, could you explain a little more about that term, IQ, OQ, PQ?
Oh, yeah, sure, Tim, no problem. So IQ, OQ, PQ is installation qualification, operational qualification, and performance qualification, and you do that when you're doing a sealer validation. So you'll install it, make sure it works, make sure it operates correctly, and make sure it performs the way you want it to. And you would do a validation and a validation report at the end of that.
All right, thank you. Greg, here's a question about dye testing. Can you talk about the validity of using dye test for seal integrity?
Dye test is valid for doing seal integrity. The only thing is, it usually checks just the seals. So if you have a hole in the surface of your pouch or tray, you may not catch it with dye. There are methods in the dye test for checking the surfaces. I don't feel they're as good as the bubble leak test that pressurizes the entire surface of the pouch or tray.
Okay, thank you, Greg. You've got a very well-informed opinion. I do know that. Greg, here's a question about ASTM F88 seal strength testing. Do you get more variation in seal strength for technique A compared to technique C?
You don't really see a higher variation you don't see a higher standard deviation from A over C. You see a higher peel value in C than you do in A, but it's not necessarily a higher standard deviation. So I would just recommend choosing one and using that for your peel testing.
Okay, I guess somebody could do enough testing to figure that out, right? Let's see, there's a question about slide 10. Let's see, slide 10. It had the voids, pictures of seal voids. Are all voids considered failures? And this person says that for their product and sealing process, they do see similar voids, but consider it acceptable. Can you talk about the acceptability of voids in the seals?
Sure. It's kind of up to you if the voids are acceptable and your inspection and acceptance criteria. They are acceptable really if the sterile barrier is still intact, but I wouldn't recommend having voids in your seals because it could lead to gross leak failures, or sterile barrier failures. So the more intact seal you can have, the better chance you have of not having leaks or failures.
Okay. I guess you could have pictures of what's acceptable and not. In fact, we have some of those in our lab. Greg, here's a question about peel testing. How do you grip a tray if you're doing peel testing on a tray?
That's a good question. So if you have a square tray, you would offset the seals. So if you're doing one side and another, you would offset it slightly so you're not gripping the tray in the same location that you're going to be doing your peel testing in. So if that doesn't make sense, please feel free to reach out to me, and I would be more than happy to talk further about that.
Okay. Thank you, Greg. And by the way, for those of you in the audience, Greg's email address is real simple. It's greg@westpak.com. Greg, here's another question. What percent of validations with leak tests do you pass, and approximately what percent fail?
Just gut feel with all the gross leak testing I've done over the years, I would say probably 90% of them pass. Pouches and trays are fairly robust and have been around a long time. So we see very few actual failures, but I would say 90% of them fail. But when they do fail, it does create a problem for our clients, because usually packaging is left to the end of the development process, and everybody's used up all the time in the timeline by the time it gets to packaging, so there really isn't room for mistakes at that point. So
that's right, that classic, we waited till the end to worry about packaging problem. We see that a lot. Greg, here's a question about pouch size. How does one determine proper pouch size in order to reduce stress cracking or other failures that we see?
I would recommend looking at ISO 11607. There's a reference document in there. I don't remember what is off the top of my head, but again, if you want to shoot me an email, I can get you that specific document number out of 11607. So.
Okay. Let's see. Another question about 4169. What's the appropriate sample size for ASTM D4169?
The conundrum, sample size. It's really up to you to determine the confidence and reliability level that you want for sample size. We did a webinar, Tim, correct me if I'm wrong, I think it was last year. We had a statistician come in and do an official sample size webinar. And then from that, we developed calculators that you could find at WESTPAK's website to calculate what sample size should be. So really the sample size is up to you, and it depends on the confidence and reliability level that you're looking for.
Thanks, Greg. And actually, I think that was 2 or 3 years back now. But for those of you, if you go to the WESTPAK website on the resources tab, you'll find webinars, and all the webinars that we've done are there for download, and also you can listen to the video. And that one on sample size is there, I know. And we also do have 3 calculators that'll help you that. Great material, and personally, I find that stuff really difficult to understand. But the guy that we hired to do that, Stephen Wallfish, statistician, really knows his stuff. A lot of good information there, and you can always reach out to him directly. Greg, here's another question about samples. How many control samples do you use to achieve the minimum test pressure?
Cool, great question. We use, per the standard, 1 sample to determine the minimum test pressure, because we don't want to have several samples that we are puncturing with a needle or a wire, basically to make the hole for the samples. So it's a sample of 1 to use to do the minimum test pressure.
Okay, that's simple. Sample size of 1. Okay, Greg, a question we have just coming in here about dye testing, another one on dye testing. How reliable is dye test, and how often is this performed for medical device packaging?
Dye testing is very reliable. It is used to check for seal, check your seals to make sure they're intact. Again, it's hard to determine the surfaces with dye testing because you have to let it soak in the dye material. we see probably 2 or 3% of our customers use dye testing to do seal validation. It's used a lot to check to see if what looks like a channel leak in a seal is actually a failure, because you can inject it with dye and look for the dye coming through versus it spreading out. If it's a failure, it'll run through in a straight line. If it's not, if it's just a puffing up of the Tyvek, that will spread out and give you this nice amorphous blob. So it confirms seal failures with dye.
You know, Greg, I think there'd be enough interest to have a webinar about dye testing. Wouldn't that be fun?
That would be a fun one.
It would. Let's see, Greg, another question about bubble leak testing. Specifically about Tyvek. How do you conduct the bubble leak test using Tyvek, a breathable material, without having false negatives or false positives for that matter?
After years of doing, excuse me, bubble testing, it's very obvious when it's just kind of fizzing out of the Tyvek, because it's running through that tortuous path on the Tyvek. It doesn't come through as a steady stream of bubbles. When you have a failure, it comes out like a smokestack out of that location. And if you run your hand over the Tyvek, while it's underwater, the fizzing will move along, and that steady stream of bubbles will stay coming out of that location. So it's really easy to tell when it's an actual failure.
Yeah, that's true. If you've seen it, it's pretty straightforward. Greg, we've got time for one more question. Can you talk about ASTM F88 compared to ASTM 1140? Which would be preferred? Any comments there?
Most of our clients use ASTM F88. The 1140, I think, if my memory serves me correct, is the dye penetration test, or burst test, sorry. 1140 is the burst test. So I would say F88 is the preferred method for that, for checking seal strength. So because you're only taking a 1-inch wide sample and you get more consistent results with peel.
Okay.
So,
Greg, thank you for those questions. You answered quite a few of them. We've got just a couple more slides in the webinar, so we'll continue with that. Okay, for your reference are the 3 ASTM standards that we've referred to today during our webinar. And of course, they're all available from the ASTM International website. If we didn't get to your question today, or if you've got a question later following this webinar, you can reach out to us through our website using the Contact Us link. You can just post your question there, and one of our engineers, or perhaps even Greg, will get back to you. You can also phone either of our 2 facilities and speak with someone there. Also on our website, on the resources tab, we have a lot of information we hope you'll find useful. We've got all the webinars from the past, about 5 years there for you to download and listen to, white papers, and some really good calculators. One of the most useful is the accelerated aging calculator. There's a little bit of information about WESTPAK. As we've mentioned earlier, WESTPAK is an independent test laboratory, and we specialize in mechanical and environmental testing. We're about, 33 years old this year, and we are accredited to ISO 17025. We are also a certified ISTA test lab. We are also 100% employee owned. WESTPAK is based in San Jose, California. We have a second laboratory in San Diego, California. Both of them can do pretty much the same types of testing, same capability. Greg and I sincerely thank you for attending today's webinar. I am Tim Eels. Thank you again.